Awesome, there we go. Hopefully everyone can see our screen. If not, let us know. So welcome everyone to our do-it-yourself or DIY hydraulic machines workshop. So this is our third workshop for our SRHack or Science Rendezvous hackathon. And I hope all of you have had a chance to look at all our different events. And there's a lot of new events that are also upcoming, and we'll talk about those shortly. So if you miss anything, everything is on our YouTube, Science Rendezvous U of T. Just search that up and you'll find these workshops. Okay, so we're just gonna get started. First of all, next slide, please. So we, as Science Rendezvous, are a group of graduate students and undergraduate students across Canada who are creating the largest science fair every year. Unfortunately, this year we had to do it virtually, but even so, it was an amazing event. We had over 1,500 attendees, and usually we have over 15,000 or more kind of attendees in our actual street events. So keep an eye out for us. Hopefully we're going back on the streets next year, but we might not. But I would just like to thank everyone for this incredibly talented and dedicated team of students who are putting together science outreach material for the public. Next slide. So I am Douglas. I'm the chair of the Science Rendezvous Hackathon, which is a new event this year. And it really started from this idea of, can we get students who are interested in coding or engineering work on a certain project together or by themselves and showcase their innovation to the public. So we have a bunch of workshops and our innovation speaking series that provides materials for students to learn about what is innovation, what is engineering, and what is programming. So today I'm joined with Lily. So Lily, do you want to introduce yourself real quick?
Yes, so I'm Lily, and I'll just be helping out with this workshop today on hydraulics. I guess I don't really have too much to say. Glad all of you guys can join.
And Lily and I are both graduate students, or were graduate students at University of Toronto. I think you worked in Kremlin, no, SickKids, right? PGCRL, yeah. And I work at Princess Margaret Cancer Center. And then we're going to do a quick intro on hydraulics. So Lily's going to lead that, followed by a live demonstration, which hopefully will be really, really fun, and hopefully it works. Doing things live is always fun because you don't know what's going to happen. And then if we have time, we're going to do a Q&A session. So let's get started. Lily, take it away. Oh, I guess there's one more slide. So this is our overall schedule. Lily, if you can click 2, 3 more times. Yeah, so this is all our events going on. So if you are a student, your time to submit a project will be from June 13 to June 20th. So stay tuned for more information there. And if you are not a student, then you can join us at our Innovation Speaking Series number 2 on June 27th. So we have amazing speakers from automated car systems to generating oxygen in hospitals in rural communities. So that will be really cool. And then we have our SRHack Off, which is summarizing all the things where the top finalists will get a chance to present their innovations to the world on July 3rd. And that's about it. So I'll turn it over to you, Lily.
Awesome. Let's get started on hydraulics. Okay, so welcome to our workshop on hydraulics. We hope that you get to follow along, learn something new, and maybe even build something similar to what you actually see here today. What is hydraulics? So we're going to define hydraulics. Hydraulics actually comes from a Greek word, which originates from the word water organ, which actually originates from the 2 words water and pipe. The water organ was actually operated by converting dynamic energy of water into water pressure to drive pipes, and typically it was actually played by hand, and during their peak popularity they were found in gardens and palaces. Now that we actually know the origins of this word, the actual meaning of hydraulics is actually applied science and technology that involves liquid in motion. So before we get into the details, a few kind of fun facts and a bit of history of hydraulics. So who invented hydraulics? There is no singular person that actually invented the concept, but many brilliant minds built upon this idea. In fact, many ancient Greeks, Romans, Sri Lankans, and ancient Chinese have mastered and utilized the arts of hydraulics. This screw, the Archimedes screw, was a majority component of ancient irrigation methods. It was the oldest positive displacement pump dating back to ancient Egypt, where it was used in the Nile. Some even believed it was used to irrigate the Hanging Gardens of Babylon, and one of the 7 wonders of the ancient world.
So
Now,
Lily, just to interrupt, for students who don't know, could you explain like just briefly what irrigation means?
irrigation is a system in which you can water plants, or like I guess water your crops in order to feed all the plants water, I guess.
Yeah, so it's kind of like a almost like an automated system where you can feed water into different areas, right? And I think that's like really innovative back in those days when they didn't have, a lot of civilizations didn't have a system where they can pass clean water to different areas. And that's why Greek was one of the examples where there was fewer kind of diseases because of innovations like this.
Awesome. In terms of, as for modern day, hydraulic systems are actually very useful and used in many machinery today, including construction machines, in car repair shops, to race cars, car brakes, amusement parks, like the Ferris wheel, airplanes, and many more. Specifically, Douglas? Airplanes?
Oh, yes. So I wanted to show this slide because so I'm not an engineer, but I was a pilot back then, where I learned to fly in different smaller planes, and it was fascinating to me how much hydraulics played a role in all the different systems where a plane functions. So, for example, if you can see in the back here, there's ailerons, and there's on the tails there's a rudder, and these systems control the airplane in terms of how it goes, so, or where it moves and things like that, and that's all controlled by hydraulics, or these fluids in these tubes and these lines. And also the landing gear, so it retracts when the airplane is in the air, but when it needs to land, the landing gears come down to act as wheels and brakes for the airplane on the ground. And then also fuel lines, so feeding the fuel to the engines. And Lily's going to talk more about those kind of things, or braking systems. They're all controlled by hydraulics and by fluids. So it's quite versatile where these systems are in play. And I would challenge you guys on the chat to type out all the things that you think that hydraulics plays a role in.
Okay, awesome. And then so the biggest advantage and the reason why we actually use hydraulic systems today is because hydraulic systems only actually need a small amount of input force to generate a large amount of power. It literally multiplies the amount of force you put into the system. And this is how someone controlling an excavator, like the one in the picture, only needs to move a joystick to direct the machine to lift up a large amount of dirt, without the controller having to actually carry the weight of the dirt. The same idea actually applies when a driver steps on a brake pedal. The motion of stepping on the pedal generates enough force through the hydraulic system to stop all 4 wheels of the car at the same time. Hydraulic systems make many jobs easier while still allowing us to be very precise. So, hydraulic systems are force multipliers, but kind of the basics. What are forces? A force is a push or pull that occurs when 2 objects interact with each other. Interactions here can happen when 2 objects are touching, or in contact with each other, or from a distance. Contact forces are what you may immediately think of. For example, when you push a box, let's say across a room, you're exerting or putting force onto the box to get it to move. The same idea is when you're pulling something such as like a string, air resistance such as on a windy day may push and make it harder for you to walk forward. Another contact force is friction, and it can actually slow down movement. Forces that act from a distance, including gravity, is where the Earth's gravity is is able to pull a falling apple to the ground without physically touching it. Other distance forces include maybe magnetic and electrical forces. So the forces that we'll be focusing on for the hydraulic system are contact forces, because we'll be physically in contact with liquids and pushing them. As we mentioned, one of the advantages of hydraulic systems is that it's able to produce a greater power or output force with a smaller amount of input force. But how is it able to do this? So in order to understand how it works, it has to actually do with compressibility, or how much you can actually compress or decrease the volume of a liquid. You may already be familiar with the 3 states of matter. All things can be divided into solids, liquids, and gases. These molecules and gases are far apart with a lot of spaces between the molecules, which allows it to be compressed into a smaller volume. However, this is not the case with solids and liquids. The molecules are closer together with less space between them, making solids and liquids incompressible. This means no matter how much you squeeze the water, you can't make it take up less space. Because liquids are incompressible, they can take shape of any container they are in, and it makes useful for any application in modern day machines. So, I guess to put it into practice, you can actually do a home experiment to kind of show the incompressibility of liquids. In a syringe full of air, a gas, if you actually block the opening and push down on the plunger, the syringe can be pushed down because the gas is actually compressible, and the volume that it takes up can be smaller. But if you were to fill a syringe with, let's say, water on the right-hand diagram, if you actually block the opening and try to push down on the plunger would not actually move no matter how much you push. And this is because water is not compressible and it cannot be made into a smaller volume. What actually happens to the force you are putting into the plunger is that it gets distributed throughout the entire liquid, and the liquid pushes back against the walls of the syringe as pressure. And so what we know from the past is that the famous mathematician and physicist Pascal made the actual same observation and came up with Pascal's principle. So what Pascal's principle says is that pressure on a fluid in an enclosed container is transmitted equally to all parts of the container. If we apply this to our syringe experiment, blocking the opening of the syringe makes it an enclosed container when you put force and push down on the syringe. You're increasing the pressure to the liquid in the container. This pressure is then distributed equally throughout the liquid, and the liquid pushes against the container with equal amounts of pressure. Lastly, the principle is actually defined by this formula. We won't go into too much detail, but the formula is P equals F over A. And P represents pressure, F represents force, and A represents area. So now that we actually know Pascal's principle, we can actually begin to answer the question of how a hydraulic system is able to generate a large output force from a small input force. Here is an hydraulic system. Imagine it is as a giant syringe. Imagine we have a plunger on one end, on the left-hand side, and we put force on it by pushing down. And this will be our input force. As we mentioned earlier, this input force will increase the pressure to the liquid in the hydraulic system. This increased pressure will be distributed throughout the entire liquid, causing it to push against the container with equal amounts of pressure. But take a look at the other end of our system. This is a much wider opening, which means that there's more liquid under it pushing up against it. Remember, there's still equal amounts of pressure throughout the liquid, so there's still the same amount of pressure at the output end. But because the output end is wider and has greater surface area for the liquid to push against, a larger output force is generated. For example, the orange arrows represent the pressure, and the size of the arrows haven't changed because pressure is the same throughout the liquid. But because the output force has bigger surface area, the number of arrows has multiplied, giving us a greater output force. To summarize how a hydraulic system works is that some input force increases the pressure in the liquid. Pressure is distributed, and equal amounts of pressure throughout the liquid is now pushed against a larger surface area, generating a greater output force. With more output force, you'll be able to lift much heavier things with relatively small input force. This is the basis of how hydraulic systems are able to allow us to use less input force to do much greater and heavier tasks, such as construction. However, there is a trade-off in hydraulic systems. Look at the amount of water displaced in the input force column. Remember, water is not compressible, so whatever amount of water we displace here is the amount displaced in the output column. As you can see, although we push the plunger down very far, we can only displace a small amount of water in the input column, in the output column because it is thin. This amount of water would only translate to a small rise in the output side because of the large surface area. So the trade-off for being able to multiply the input force to get a larger output force is the amount displaced that occurs on the output end. Now we actually understand the concept of hydraulic systems. Let's think of some real-life applications. A very simple example we can think of utilizes the concept we just learned as a hydraulic car lift. Think about it this way. As a person, we can't lift the car by itself, but with the help of a hydraulic system, we're able to generate a greater output force with only a small amount of input force. This is applicable in many different case scenarios. Another one being the brakes in your car, and it's a good example of a basic piston-driven hydraulic system. So when you press down on the brake pedal in your car, it pushes on the piston in the brakes, and then it translates over to the other pistons at each wheel, and it actually presses on the brake pads against the brake motor to kind of stop the car. And then lastly, another real life example, just riding your bike. So the brake lever actually uses kind of a hydraulic fluid to transmit force from your hand to the brakes. And the handle presses a kind of small piston. So like when you're riding a bike, you grab hold of the brake handle and it applies a small amount of pressure, but your whole entire bike brakes. So the smaller pressure that is applied, a large amount of pressure is applied to the wheels, and it causes the entire bike to break. So those are some of the real world applications that we have. But if you want to kind of learn more, there are other examples that you can actually find on YouTube. So if you want to do or DIY at home, some examples would be making this X-Men Wolverine claws, and you can actually make the claws using a hydraulic system. Or even a hydro-powered robot arm. Another example would be building a hydraulic bridge. And then another one would be making a hydraulic press. But today we will be showing you only one example of the things that we will be doing.
Yeah, so just to interrupt, if you can go back to the hydraulic arm, like the robot arm, Lily. Yes. I think so. This is really cool because it showcases that. So Lily did a great, presentation on how you can use hydraulics to create force, right? So in this case, you can make this hydraulic arm move in 3 dimensions, or I think even more, right? So here the pincers can open or close. It can rotate its arm left to right. Its hand, and then the entire system also can change. So for every syringe you see on the left, it's a different movement for the crane to move. Now, if you go forward, Lily, so next slides, one more. Yeah, so back to the press. Go back.
Here. This one.
One more. Yeah, so this is a great example of is the slides glitching? Is that why? But if you go back to the press, so this is one of the examples of what Lily meant by having a small input and a big output system, is that just by kind of pushing your hand in the syringe, and it doesn't take too much force, because you're changing the surface area, the press itself has so much force that it can actually push down and crush the can. So that's actually a really cool demonstration of what we're mentioning. Now, next slide, please. So today we're going to look at a hydraulic lift. And I actually have an example here, which I made a couple nights ago. And hopefully you can see it through the Zoom background, but let's see. Yeah, so this is kind of the lift. There were a lot of kind of challenges that I kind of went through. So this is attached to a syringe here and another syringe here, right? So it's hard to know when I'm lifting it up, but once I kind of push on the syringe, this hydraulic kind of lift will rise, and then that will push this up, and it'll go up and it can lift things. So we're going to build this today, but there's, again, so many different applications to showcase. And I think I also saw a couple of people asking if you actually have water in your bikes. So it's not necessarily just water. People use different oils and fluids with a higher viscosity, so it's thicker. And part of the reason for that is also it allows it to not freeze in colder temperatures. So it has a lower kind of temperature where the fluid actually kind of freezes. So that's another question that someone asked. But you're right, like if it gets too cold, then that can change how the fluids can work in our different systems. Yeah, so great question. Okay, so we're gonna actually take a 5-minute breaks. And during this 5 minutes, if you guys can go and collect these tools, so we'll leave this up here, but we're gonna start our next demonstration or the actual workshop. And so if you guys can get 10 mils of syringes, if you don't have syringes, that's totally fine. We can just make the lift today, and maybe another day you can make your own syringe, or you can purchase a syringe from arts and crafts stores, or even bakeries and stuff like that. Or even department stores have syringes. They call them oral syringes. And yeah, so 2 of those. If you don't have it, that's okay. We need skewers, or if you don't have skewers, toothpicks would be fine. So 8 of those, and also cardboard. So we need 3 different types of cardboards, one for the platform, one for the base, and one for the arms. So you can get kind of big pieces of cardboard, and if you can't cut it in time, that's okay, we'll do it together. Scissors, X-Acto knife, tubing, ruler, and pencil. So for the tubing, again, if you don't have it, that's okay, we'll just make the crane for today. So any questions? If you do, post it on the Q&A and our team will answer it. And yeah, so that's about it so far. So we're gonna break, and maybe Lily, if you can play some music, if you have kind of Spotify, then that'll be great. If not, then we'll come back in 5 minutes. So we'll see everyone at 1:30 and just collect all these tools. everyone. So Lily, can you actually like share screen again? So we need just a couple more slides and then we can start the demo. So hopefully everyone had a chance to grab everything. There were a couple of questions. So toothpicks or skewers are fine. I'm going to use skewers because I find that they have a lot more support, but it's okay if not. And also we do need all three platforms of cardboard. And so we have these three here that are cut out, and I'll show you again in a sec. And if you have a bigger cardboard as your table, then that's also preferable because your parents would not be too happy if you cut up their desks or the floors and stuff like that. And just a kind of warning for everyone. So we're going to be using X-Acto knife, scissors, and stuff like that. So just be really careful. And also, if you are younger, then please have a parent kind of supervise you because it is quite sharp and quite dangerous. And so just be really careful or ask a parent to help you out. Okay, so next slide. So that's what we're going to try to make today. Hopefully we can do it all in 30 minutes. I have hope. So I wanted to show you really quickly about schematic diagrams. So I'm not an engineer, but when I was younger in high school, I did a lot of designing stuff and trying to build stuff. So I made a little wooden airplane. And what a lot of designers and architects actually do, you can look at this screen where I'm sharing on my phone. So you can have different schematics of the front view of the plane where there's a propeller and then the wings. This is an older plane. And then a top view with all of the measurements and the dimensions, and also a side view. So this is what hopefully you're aiming for as you get older and get more experience with drawing designs and prototyping or trying to engineer or build things. So I did a really quick sketch and I didn't have too much time. So this is what it looks like for the platform. So here we have a top view. On the left is where your Coca-Cola can or whatever you want to lift is gonna be set on. And then on the side, it's the syringe. So kind of like this is your view. So from the top, and then Lily, next slide. This is going to be the side view. So the actual crane, the platform, the base on the bottom, and the two syringes. So this is how I kind of plan different things. So if you guys can get in the habit of doing that, then that would help you so much. Okay, next slide. So we have different cutouts of cardboard. So we have our platform right here. So I labeled that platform. Sorry, it's a little glitch. It should be 18 centimeters by 12 centimeters. So I can right now kind of draw it out with a ruler and with a pencil, then just to get you guys started. So that will be a important component for the whatever you're lifting is going to lie on. We have our arms. So Lily, next slide. Sorry, one more. So this is, or legs, I guess I called it here. So this will be 16 centimeters by 12 centimeters. And this is where the legs of the crane are going to be. So the ones that you see. And the final one, so go back a slide, Lily. This is the base. So I modified it a little bit. It's actually going to be 30 centimeters by 14 centimeters. So take this time to kind of cut those things out. Lily, if you can go back to the first slide with all the materials and things like that, just to show them one more time, and it'll give you a minute. So draw it out on a piece of cardboard and ruler and everything, and then using an X-Acto knife, following the lines. Just be very, very careful of your fingers and don't obviously put your fingers where the X-Acto knife is going to end up. So be really, really careful and have your parents to help and just go across that line very slowly. And again, as a final reminder, use cardboard or another surface that you don't mind scratching because the X-Acto knife is going to go down. Right? So yeah, make sure we don't anger your parents with scratching desks and floors and stuff. So I'll give you a minute to do that. And then, so keep the PowerPoint on for a sec, Lily. And then we'll just to show them the centimeters and stuff like that. And also for the students or participants, just write down these dimensions, and then we can get started. Okay, so I'll give you 10 seconds, and then Lily, turn off the PowerPoint, and then the other Lily on our team, we have two. If you can kind of spotlight the one that I'm doing, like that's showing everything, then that'd be great. Okay, let's do that. All right. So step one, this is the arms or the legs. So again, this is 12 by 16. I think you can just spotlight that one. Let's see. Yeah, okay. This might be easier. Let me know if, for the students, if you're seeing the demo. Okay, so this is our arms. So what we're gonna do is we're gonna take a pencil and a ruler, and we're gonna measure 2 centimeters going this way. So for every 2 centimeters, you're gonna make a mark. So I'm sorry it's a little blurry. Don't have a fancy camera. So for every 2 centimeters, make a mark. We're gonna make the arms. Oops. And then this is gonna be 8 of your legs. Awesome, thank you for Lily for posting that. And then also from the top side, you can make notches if you want. Just for the sake of time, because I know we're kind of tight, I'm just gonna wing it. Okay, and then we're gonna cut along these lines. But before that, we're gonna do a couple of measurements. So let's measure the middle of this cardboard arm. So this is 12 centimeters. So at 6, we're going to make a mark at the very middle of each of these rectangles. So I'm gonna make a mark here. Maybe I should use handy dandy marker. And Lily, feel free to interrupt me if I need to answer any questions or things like that, or slow me down if people mention it's too fast. But unfortunately, we have limited time. So, okay, at the bottom and at the top, we're going to make a mark at 1 centimeter. So you see 1 centimeter here. We're going to make a dot there. So this is where all the skewers are going to land, or toothpicks. So I'm just estimating here. But if you were to do it, you can measure it really down to the nail, just so it's a lot more, it functions a lot better that way. But because of time, I'm winging it. Okay, any questions so far? All right, so now take your X-Acto knife, again, careful and parents. So I'm just gonna cut across here to free up my arms. I'm also afraid of cutting through this cardboard and ruining my own desk. And also thanks everyone for attending. I know there's a lot of events for SRHack, and I'm really looking forward to all the projects that you guys have shown through our Discord channel. There's a lot of really, really cool ideas, so I'm super excited. And again, if you have any questions, ask our mentors, you can email us. And even, so we're doing hydraulics today for the reason that it provides a way of movement for whatever innovation that you want to design. But you can also do other things, right? You can use elastic bands and use elastic forces. That's why it's really cool for Lily to kind of mention all the different forces that you can use, right? Some people use mouse traps to power these wooden race cars that people have made, or there's other ways of doing it. Okay, so now we have 8. I really hope it's not glitching too bad. Now we have 8 kind of arms. So what we're going to do is we're going to cut just the corners of all of these rectangles. So on all these sides. And at least for the ones on the top, it helps it give it movement and degrees of freedom where the objects can actually move. And you'll see how that works in a sec. How am I doing on time? Okay. 20 minutes, all right, let's go. So just the corners. Is everyone following along? You type in the chat, or maybe you're too busy cutting. Yes, so recording is going to be shared on YouTube after a couple of days. Our team is a little bit overwhelmed right now, so if it's not up within 2 days or so, 3 days, you can let us know. Yeah. Any other questions? Has anyone wanted to be a pilot before? Or if you guys have other ideas for workshops in the future, please let us know. Okay, cool. So we have our dots, right? So what we're going to do is we're going to poke holes in all of this. So this is where the skewers are going to enter. You can use a pen. That's what I did last time because I was really impatient. But I'm going to use a nail. I guess I should have brought my hammer or a actual nail. Let's see if this is going to work. I give up. Let me find a pen.
Oh, one of the people asked, his arms are too thin. Will it still work?
Yeah, so because it's cardboard, and that's why you can also use popsicle sticks, and that will give it more integrity, but hopefully it'll still work. Ideally, you want to create something kind of more sturdy. And so that's why I used about 2 centimeters, but you can do a bit more. And it also doesn't, like, you can try it out next time as well, right? Like you can redo it and see what works, what doesn't work.
Someone also asked, Sherry asked, where did you get your cardboard?
So I bought a lot of things recently from Amazon. So you can ask your parents to get some cardboard from their shipping stuff. Or I know like places like No Frills also has like cardboard boxes where you can kind of pick up. And it's really good with our kind of theme for Science Rendezvous this year is sustainability. So you really want to, and that's part of our engineering project here, right? Like how do we use household items and how do we repurpose it or reuse it in different ways?
You can also pick up some cardboard through Costco. If you go to Costco, they always have those cardboard boxes and you can reuse that. Someone asked, how much is the cardboard? I think it depends. I can check.
Cost-wise, I got it for free, so. Lily, have you done a lot of arts and crafts things as a kid?
Yes, I did a bunch. Dollar store was my favorite place to go to get supplies.
What's your favorite, like, what's your most memorable art project?
Probably origami. I did a lot of origami when I was a kid.
Oh,
Costco
nice.
cardboard. Yes, high five. Love Costco.
Okay, so, we're trying to do all this with the time that we have. I wish this was like 2 hours, but I don't know if the students would sit through this for 2 hours. Like, I'm sure I have a short attention span enough. Okay, so what we're going to do now is we're going to here are my two kind of legs. So we're going to poke through our skewer or toothpick, the top of the first one, and then we're going to put it through the bottom of the other one. Just be careful of your fingers. Okay, so we're just gonna leave it like that for a second. So that's one of my skewers. How glitchy is this, Lily?
It's
Was it
okay.
blurry?
It's not super bad. Sometimes it kind of freezes a little bit, but it's not too bad to
Yeah, I
follow
wish I
along.
had better camera quality.
Yeah.
Am
You
I
can also,
like speaking through? Yeah,
no, I was just reminding the students, you can use toothpicks for this step, not just skewers.
yeah. So I've done two of these so far. Where you have two arms with the two skewers. So let me just think. Oh my goodness, I forgot how to do this probably. Okay. So we're gonna do two. And then what we're gonna do is we're gonna push these skewers all the way to the back. So the angle right now, it doesn't matter too much, right? So for the skewers, I'm gonna push it all the way to the back. For the toothpicks, people, you can just ignore this step for now. And I'll show you what I mean in a sec. So now on the end of this skewer, I'm also going to do this and do the same thing. So put them two together. So for people who have toothpicks, these are going to be separate sticks, right? So you're going to have one toothpick on this one and then one toothpick on the one that's in the back here. So right now they're kind of, looks like a little house with two triangles, right? I hope this works because I didn't do it this way in the first try. I think that this makes sense. Ooh, okay.
How's everyone following along? Is it okay?
Okay, so now what we're going to do is that we're going to connect these two pieces together. So, and how we're going to connect them is we're going to, so if you have a toothpick, then you can see it like this. Anyways, you can put the two triangles together, and at the very center of each arm, you can see that there's a hole, right? So you're going to take another skewer and then piece it through there. Okay? So I'm going to go from this end. Okay. And then for people who have skewers, so once you do it on one end, you can do it on the other end. So again, you want to make an X, and then you're going to feed it right through the middle of each of the arms. Yeah. So do that. So be like careful. Awesome. And we're going to do it for the bottom ones as well. And so I'm not going to do, yeah, sorry, the video quality is a little bad. And there's nothing we can do about that, unfortunately. I wonder if I should do it on my computer.
Would it be clear on your computer?
Let's see.
We also have, we can also link some of the YouTube links at some point too. The examples that I showed as well.
Yeah, I think that would be good. So we'll give a link for that as well. Hopefully you guys are just kind of following along for now, but let's get rid of my background. Is there a blur? No. Okay, so let's see all my fantastic room and everything. Okay, this is dual view. So hopefully this will help. I think this one's cleaner. Okay, so
Harry asks, what do you call this contraption?
this is called a hydraulic lift. So you see it a lot on car stores and car garages where people fix your automobiles and stuff, where they have lifts to lift things up. You can also see if your parents are changing tires. It might not be the same mechanism, but it's very similar in a way. Okay, so
The same idea.
Yeah, awesome. So now you can see it's not totally even, and I'll tell you why. So these skewers, the in-between of the skewers, like technically we should measure it if we have time. And also sometimes you can put, for example, a tubing like this. So you can, or a straw, cut this out and then put it in the middle. And then that will help stabilize your contraption because it won't kind of bend inwards when we're doing it. So this is just like a very simple kind of basic way of kind of guesstimating it. And you can see that when I pull it up like this on the bottom ends, then the contraption goes up, and you can probably see it better in this camera. And then if I kind of like squish it down, then it goes down. So everything can be controlled just by moving the legs down here. Right? Okay, now for the rest of your skewers, just push it through the remaining holes. So how much time do we have? Not a lot, right?
The tubes you can actually buy probably on Amazon as well.
Yeah, so Amazon or also aquariums or pet stores, they have them there. And I think on our, we'll send a area or examples of where you can find it. Because also department stores like Canadian Tire or Home Depot, you can find. So we don't have time for all of this. So we were going to use a platform and a base. Maybe I'll have time to show those, but we'll try to simplify it.
Sherry asks, will you demonstrate the straw? Still don't understand what orientation to keep the straw.
The straw. Okay, so I won't demonstrate the straw, but so this is a straw or a tubing. So what you can do is before you put the skewer inside, you can feed the skewer right inside the straw like this, and then push it all the way through like this, and then cut off the straw here. So you're essentially having a plastic tube, and make sure they're all the same length, right? And then in that way, it will cover this part of the skewer. So then it would prevent the cardboard pieces from coming in and then squishing inwards, right? So I think that's a little bit more advanced for another kind of day when we have a bit more time. And just need 2 more skewers. Try not to stab yourself like I did. Hopefully you guys can buy a set of skewers and then go barbecue. Such nice weather. I think literally we're doing, me and my family are doing Korean barbecue later, so skewers will come in.
So jealous.
Yo, I can't wait until our exec team just goes out for dinner and stuff.
Yes.
All right, so
glad you like it.
that's that. And then what I'm going to do is I'm going to cut all the ends, not too close. You want a little bit. So you can use scissors. I'm using this tool that I don't know how to pronounce. What would you call this? A pincer?
There is a term for it. I don't remember the term for it.
And then I'm just going to leave the last one on the bottom left over here. Just going to leave that one. Oh, I got to clean it up later. It's like flying all over my bedroom. Ooh, that hit my laptop.
Someone said wire clipper. Cutting pliers. pliers.
Yes,
Pliers.
cutting pliers. And this one as well. So what you can do now is you can, let's see, how much time do we have? 5 minutes. So you can heat up your glue gun if you guys have a glue gun, or if you have one ready. So just to demonstrate again, by pushing just this one on the bottom left, your invention can kind of, or the lift can kind of go up. Do you see that? So what we're going to do is we're going to, let's see. Yeah, so heat up your glue guns. We're going to do a very basic version because of time. And then you're going to take your base. And then you're just going to glue the bottom ones right here. So the bottom of the leftmost ones. So just glue the cardboard of the arms onto the base. So only these ones, not this one. If you glue this one or both of them, it's not going to move, right? So you're only going to glue the bottom one. So as we're waiting for that to warm up, we're going to prep the syringes. So here is some liquid. So this is from my painting earlier today, but you can use like dyes or just plain fluids. So you're gonna suck up your syringe. This is a 10 ml syringe. And it's all filled out like this. And what's gonna happen is I'm gonna take a tubing. Let's see, here's my tubing right here. And then I'm just gonna guesstimate. I don't have to have a very exact amount. So I have about this big of a tube, right? And then we're going to attach it to the syringe. We'll probably run 5 minutes over time. So if people would want to stay, you can stay. If not, then it will all be on YouTube. So now you're going to have to squeeze the syringe so that the liquid comes out of, so you can see it's coming out. Where did I get cutting pliers? From my dad. You can also get it from Canadian Tire or hardware stores. So once you squeeze out all the liquid, you're going to suck the liquid back in. So now we have a syringe that's fully immersed in water. So even the tube has water in it, and make sure there's no air bubbles. Then we're going to attach the end to the other side of the syringe. Make sure this syringe is completely on the closed side, so there's nothing there, right? Not on the open side, like that. So all the way to the closed side. And then you're going to attach the tubing with the syringe. And then now you have these two syringes with the tubes, right? Like that. So when you press one, the other one's gonna move, right? So that's how you're gonna control the current. We're gonna press it on one side, and then the other side, it will move, okay? So what we're gonna do is, I'm gonna move that liquid away. We're gonna attach one of these syringes right on the wooden side of the bottommost one. So like there, and you're gonna glue gun that. Also try not to touch the end of the glue gun. I'm just doing it to see if it's warm.
Sure.
Yeah, so
what's the blue colored fluid made out of?
It's just acrylic paint right now because I was just finishing painting this morning. But you should probably not use any paint related things because that might clog the system. So just use clear water or coloring dye. And yeah, we can go 5 minutes over time. I think that's okay at Lily, right?
Yep. We'll be here. It just depends on if you guys want to stick around to watch.
Yeah, so we're almost done. I'm just trying to make an abridged version of this. And so again, the ways to make this work better is what you can do is you can do a glue gun here at the edge of every kind of like skewer, not to the bottom, right? Because you don't want to fix this and make it not move, but just at the top. So like a bulb here, so that the cardboard doesn't move. And you can also do like a little blob of glue gun there. Or you can do the straw idea. The straw idea, again, would be here on the skewer so that it will prevent the cardboard from moving inwards. And what we're going to do, it's about warm. Again, be careful because it's kind of hot. So we're going to glue these two ends onto the cardboard base.
Yep, we can give you a link. And there'll be also a link online when we upload this.
And then we're also going to glue this syringe onto the middle of the wooden skewer. So all right, just letting that dry. And then we're going to glue the bottom of the syringe, onto the base of the cardboard. So I'm just going to go under here.
I would say, to answer Sherry's question, she's like, ball-shaped glob or bead of hot glue at the ends, end cuts of each skewer. So asking how much hot glue, I guess.
A little bit, just like a blob, enough for the cardboard not to move outwards, but you, again, don't want to glue the cardboard and the skewer together. Okay, so we're going to let it dry a little bit, and glue dries really fast. So to summarize again, during these back two areas on the bottom, I glued it to the base. I glued this syringe part that moves to the skewer here, and then I glued the base of the syringe to the base of the board. So that will fix this side. And what's going to happen is when I push the syringe and the liquids through, this is going to move the skewer, and then the whole thing will lift. So I'll show you what that looks like here before we glue on the platform, and then that's going to end it, right? I mean, that's the end. So here I have the syringe. Hopefully it's dry. Okay, so hopefully it works. So as I'm pushing it, can you see that slowly this kind of moves up? My background stuff in my room. So it rises. You can see that? Yay.
Looks great.
I think that's a Lynn that I know. Hi, Lynn. Oh, no. Okay. So, yeah, when I pull it back, it's supposed to stay with me. So right now I didn't apply enough glue, or what you can do is you can tie it with rope or something. So when I pull the syringe back, it goes down, right, like that. So I'll show it to you one more time. And it's not gluing, so we'll go how to fix that. But once you push the syringe, the lift lifts, right? Okay, so again, you'll have to secure the syringe to the skewer a lot better. And then what we're going to do is we're going to put the platform on. So what we're going to do is we're only going to glue these two onto the platform. So not both ends, just this side. Because again, if you do both ends, then it's not going to move properly. So blob of glue. Oh, it's falling. I haven't used a glue gun in so long until like a few days ago. Oh, it's hot. Try not to burn yourself. Okay, there's a platform, let it dry a little bit, and then I'm also going to reinforce it. So this is important to make the platform stay. We're almost done, guys. Sorry it took a little longer, but hopefully it was worth it. How are you guys doing? Like, how's your Are you guys following along? Or is it a little too fast?
How would you calculate how much weight the hydraulic lift can lift?
That's something you guys can do with the experiment, I guess. Too fast. So you guys can view our video again. Yeah, so you can test and put different things on it. Let's put this wrench. See if it works. Sometimes it doesn't balance evenly enough. And I think, again, the straws will help. And also the blobs of glue will help. Oh,
It's moving.
yeah. This guy's really heavy, so okay, maybe let's not start with this. Maybe something lighter. And again, I think where the weight is at is the bottom of the cardboard here. So make sure you glue it properly. So again, because of time, I didn't have the chance to like really secure everything. So with the pen, it can elevate, right? So now let's try maybe my scissors. Also, again, be careful of your X-Acto knife. Yep, you can lift scissors. You can also lift phones and stuff. I think that would secure it. So again, the weak points here is the syringe attachment here, and then also the base attachment over here. So if you glue it enough, then that should work. Awesome. And I noticed the scissors just fell out.
Scissors fell into the thing. You guys can
Yeah.
also get creative with the
Purple one.
hydraulic lift. If you guys want, you could also maybe like make a phone holder or like a phone lift or something of that sort.
Okay, so Lily, can you show the PowerPoint slides again?
Yes.
So we'll just end it now as I re-secure these attachment points. And it's just a lot of, with engineering, it's a lot of testing things, right? So if things don't work out, you ask why, or like, were there calculations that I missed, or are there attachment points that are not glued properly? I think that's all part of the learning process. So don't feel bad if it doesn't work right away. This takes time to learn. Awesome. Okay, so at the very end slides, Lily. So we're just gonna end it here. So thank you everyone, our SRHacks organizing team. We have Mimi, who's lead of engineering, Eduardo, lead of programming, and Adis doing getting our different speakers and organizing some workshops. We have Blake with all our logistics and emails, and then everyone else who's helped out, especially Lily. Next slide. Thank you to all our sponsors. Without them, it won't be possible. And last slide. Yeah, and that's it. We don't have time for Q&A. What I'm going to do a quick kind of side view for you guys to see. Let's see. And then we're going to call it that. And I can go have my coffee and stuff. Okay, so
Sherry, okay, just a few questions. By the time everything dries, what do you need to do to lower the platform? So you pull the syringe.
yeah, so if you pull the syringe down, the platform will lower. That's if your thing is attached properly, right? So if you pull it here, pull it down, hopefully, oh, it is. It's lowering. You see it? So I'm pulling it out. And then if you push it in, then it'll expand.
Yeah. And then James was like, why don't you make another one? Then flip it upside down. Then you got a hydraulic press.
Oh, that's smart. Yeah. So you can definitely do that. And I think for presses, they need a lot more force. So you have to play around with the different kind of syringes, whether it's one small one here and then a bigger one kind of at the attachment point. So yeah, those are all good ideas. So hopefully it's kind of clear here. I know things are kind of falling apart because I didn't let it enough time to dry. But yeah, thank you everyone for here. Hopefully you guys can make one and show us, send us a picture or to our Instagram people. If you're on Instagram, or send us to your email, just tag us to show how your lifts look.
Yeah.
Okay.
Thanks for joining.
Awesome.